Yes. It is going to, the answer has to have 2 decimal places because you're doing addition last. All right. So let's look at this real quick and look at what our final answer should be and all of that. And I did not round it to the right number of sig figs yet because I want to talk about that. That's where I want to be very intentional today about making sure, because there's 2 questions in active that the sig figs will kind of trick you, especially the way they're phrased. So going through here, we set up our isotopes. So we had 4.300% of 49.946, 83.80% of 51.941, 9.500% of 52.941, and 2.400% of 53.939. All right. Now, when we do those calculations based on the multiplication on each one of those, our answers should be in 4 sig figs. So, on the first one, it's going to be 2.1476. That's where you're stopping, is at that 7. 43.52. That 2 is technically where we're stopping, but I'm not going to round until the very end. 5.029 is the. I'm doing 4 sig figs on each one. That's 4. 1, 2, 3, 4 is the smallest amount. 1, 2, 3, 4 is the smallest amount. 1, 2, 3, 4 is the smallest amount. The percents, these zeros, count as sig figs too. So everything, this is 4 sig figs. Oh, that one's 5, but the rest of them are 4. 1, 2. Oh, it's 4. Sorry, I just misread it. So all of the percentages are in 4 sig figs. So all of the multiplications have to be in 4 sig figs. All right. So same thing there. All right. Now, when we go to add them, basically, when we go to add them, our least precise number becomes that 43.52 because it's the only one, it has the fewest decimal places. So because it has the fewest decimal places, when we're adding, that's what drives adding, subtraction. Number of decimal places drives our answer, not sig figs. So our answer can only be 2 decimal places, but I have 51.998. So how would I round that to show 2 decimal places? What should our answer be? The answer that you would type in is 52.00 because that 8 rounds the 9 up to a 10, which rounds the other one up. All right, so you're not double rounding there. You're just carrying the 1. All right. So, and the reason why I pulled this one is a question that I mimicked off of one of the exams from about 3 years ago that just about every one of my students missed. And so they've gotten better with the active questions as well as being very specific of it. So if you, I don't know how many of y'all started in it, but if you're looking at question 25 in active, and so, and I'm kind of giving you the answer here, but so look at the question, look at the answers, look at the work that they showed from active on there. Why should the answer be 51.6, 51.7, or 51.5, however they got there? I'm not sure. But why should it be 51.6 and not 52? Why? But how many sig figs is this?
2. But it goes off the percent.
All right, so let me add, I'm trying to get y'all to tell me this though. Why am I not concerned that those are 2 sig figs? What type of numbers should those be representing? Oh yeah, they're mass.
They're presenting like numbers you can't change. Like the 12 dozen eggs you can't change.
Okay. What type of number is the dozen? It's an exact number. So remember, an exact number won't affect our sig figs. So the reason why I wanted to point this one out. So if the only mass they ever give you is one in a isotope notation, we treat that mass in the isotope notation as an exact number. So in that, our calculations are going to be based off the percentage this time. So when we look at this and we do our, initial calculation, so we get 46.92 because that's 4 sig figs. The 8% is only 3 sig figs, so it's 3.92. The 3% is only 3 sig figs, so it's 1.50. Now we're adding here, so I still disagree with this. Well, one, because they use different numbers in their bottom calculation than they did in their top calculation. But two, because this one is 4 sig figs, and it's going to give you 2 decimal places there. Each one of these gives me 2 decimal places. So I still argue that my answer should be in 2 decimal places. And I'm going to have to go back with Dr. Sri on that.
I think on some of them it's like if you give the wrong decimal, like if you give the wrong.
It still gives you right, but I'm trying to compare this to what Southeastern is going to do. So I need to go back and justify that again. But what they're saying is because all of those are exact numbers, they were expecting only, I think they messed up and intended for this to only be that 0 not to be there. Go ahead. You need to start taking care of that before the bell. But what they're saying on that one is because of the, it should have been 80%. All right. Now, coming to this one. This one's a little bit better because it is done right because I double checked this one. But looking at this one, so I typed in 51.7 for my answer, and they said the answer should be 51.76. All right. What about this one, based on the work there, makes my answer should be 50. Okay. So if I look at all of these calculations, the second one, the 8% and the 2% are both 3 sig figs, so those answers have to be 3 sig figs. But when I do the calculations, and I'm looking at the sig figs on there, so this one is 4 sig figs, so it goes to that 3. This one is 3 sig figs, so it goes to the 1 there. And this one is 3 sig figs, so it goes to the 0 there. All right. So when I add those up, I get 51.757. But notice every one of those are in 2 decimal places as far as my sig figs are concerned. So I go to 2 decimal places on this, and it's actually 51.76 because I forgot to round the 7 to the 5. So it's the correct answer, 51.76. All right. I'm stressing this because I know y'all know how to get to the right answer, but I don't want you to get marked wrong on a test because of a ticky-tack thing like that. So I want y'all to really, really reason it out. Don't overthink it, but I really want you to pay attention to what's going on, especially when you have multiplication, division in a problem, and then at the end you have addition, subtraction. Or if you start with addition, subtraction, then go to multiplication, division. I recommend not trying to work it all out as one problem and then figure out the sig figs at the end. I recommend doing it piece by piece. That way you can see where your answers are supposed to be. Yes?
If we do put 51.7 on the test, we'll get it wrong.
Yes. That they are looking for sig figs on this test. So this one is really strict on sig figs. They loosen up a little as the semester goes on, but it's better to always go for the sig figs and get the right answer, their expected right answer every time. They don't do partial credit on the tests. I wish they would. Because if you show all your work and you got there, you have the right answer. You just didn't understand one little minute rule. Yes? Mm-hmm. No, it'll only ever have one. Just like the quiz that we took. You get a question, and it'll have a box that you might type in a specific answer. And those are going to be the hardest ones to get exactly right. And luckily, there's usually only 2 or 3 of those ever on a test. But the problem is if you the way the Moodle test is set up, there's 25 or 30 questions. You're missing 2 or 3 questions. You're already down into the B range. So that's the good and bad of it. All right. Now, so yesterday we ended up right here where we I gave you a periodic table and had you kind of section things off. So this one is a little cleaner of what I want you to know. So everything to the right side of that stair step line is the metals. Everything to the left side of the stair step sign is the metals. Everything to the right is the non-metals. And then the stuff that goes along the metalloid line or along the stair step line is the metalloid. Now, I did notice in your the way it printed, it had darkened. I think it went like this, and then it went down 2 right there. That's showing you the outer edge of the metalloids rather than what I usually show is the, I usually show it like this. The line that they were showing, they showed it like this, I think. Just be mindful that the metalloids are everything that kind of touches it with exception of aluminum. And do realize that these groups down here also are part of that. So what I wanted to kind of look at with this and where we're going now is, so this is one way that we isolate things on the periodic table. All right, we separate them into regions, we separate them into these areas. But, and I don't know that we're going to get all the way through this today, but the next way is we start identifying the elements by groups. So groups are the columns on a periodic table. So groups on the periodic table represent a column. The groups are numbered, and they're numbered a couple of different ways. So if you look at your periodic table from the reference packet, notice that they have numbers going across at number 1 to 18. And then they have these Roman numeral numbers that have like 1A or 2B, things like that. All right. The A groups are considered to be main groups. The B groups are considered to be, they're part of the transition metals. So the reason why we put elements in groups like this, so I'm just going to use group 1. So we have hydrogen, lithium, sodium, what is it? Sodium, potassium, rubidium. All right. What's one thing that we've already learned that all of those elements have in common? I had y'all fill in something on the top of your periodic table the other day about all of them. They are metals. What about the ion? It is a +1. So all of these form a +1 ion. Now, another thing that makes them form a the reason why they form a +1 ion is all of these have one valence electron. A valence electron is an outer shell electron. So every one of them in that column has one valence electron, so it's easy to give that one electron away. All right. So that was group 1A. All right. On the opposite side, we have group 8A, and that's things like helium, neon, argon, and so on. All right, our noble gases. With exception of helium, helium's a little bit different because it only has one shell. But how many, what did we say was special about the charge of these? They don't react. They don't make ions. They have a zero net charge because they're non-reactive. Now, the reason why they're non-reactive is because all of these have 8 electrons in the valence shell. All right. So, and so our goal is to get to 8 in the valence shell, get a full outer shell. So essentially, they're either going to try to get to 0 or 8, and whichever's closer. All right. So if I look at column 7A, which is that with fluorine, chlorine, bromine, iodine, I want you to make a prediction based off the pattern you see there for valence shells. How many valence electrons should group 7A have based off the pattern you see? Valence electrons. I'm not talking about charge yet. If group 1A has 1 valence electron and group 8A has 8 valence electrons, 7. So whatever is, if you're looking at the ones that go 1 to 18, or if you're looking at the ones that have the Roman numeral with the A's, whatever number is in the ones place is the number of your valence electrons. So group 7A has 7 valence electrons, valence shell electrons. All right. Now, how many electrons does it need to get to 8? 1. So what charge will it make if it gains 1 electron? -1. So that would make -1. Looking, and I'm not going to write this one down, but looking at the column that nitrogen is in, it's group 5A. How many valence electrons does it have? How many valence electrons does it have? 5. All right. If nitrogen is in group 5A, it has 5 outer shell electrons. How many electrons does it need to get to 8? It needs 3, which it makes a -3 charge. All right. So, again, going on there, those numbers across the top can tell you that. I gave you the other day, I had you assign certain numbers as far as charge based on location, and it's based on the number of valence electrons. It's easier to get to 8 if you have 5 electrons in the valence shell than it is to lose 5 electrons to get to a 0. All right. When you get to carbon, those all have 4 valence electrons. That's why I said it can be a positive or a negative there, because it's just as easy to go one way as the other. All right. So that's kind of what we're looking at on the group. So remember, a group is the column. There are 18 groups on there, or 18 families. Groups and families, I'll use that term interchangeably. But the main reason why they are grouped the way they are is because they have the same number of valence electrons in that group. All right. They also have similar chemical and physical properties. So like group 1A, we said the other day that group 1A is highly reactive with water. They're highly reactive in general, but they're violently reactive with water. All right. So I'm going to get as far as I can with this. So group 1A, or group 1, they are called the alkali metals. I think I gave you all that name the other day. Group 1A is the alkali metals. They are metals. They have 1 valence electron, and they tend to lose that electron to become a positive ion, or a cation. All right. Group 2A. Oh, the other thing I'll say about them is they're very reactive. If you want to, I'm just throwing cation to get y'all used to hearing that word. All right. Group 2A is alkaline. So alkali is 1, 2 is alkaline, and it's sometimes called alkaline earth metals. The things that we need to know about those, again, they are metals. They have 2 valence electrons, or 2 outer shell electrons. So remember that valence means outer. Is it 2 T's or 1 T? All right. So when I say outer shell electrons, I mean the highest energy level, the most outside energy level. All right. They have 2 outer shell valence electrons. All right. They tend to lose those 2 electrons to become more stable, and so they make not a +1 charge, they make a +2 charge. All right. I'm going to skip a couple of these and come back. All right. +2 charge. All right. So I'm going to go from noble gases. So I'm going to start on the other side. Group 8A or group 18. All right. Group 8A is very, very stable. They are mostly non-reactive. They mostly do not react, so they are considered to be inert. And in fact, another name for this is the inert gases. All right. The reason why they're considered to be stable is because of this being filled valence shell, they have a full outer shell. A full outer shell means that it has 8 electrons. Helium has a full outer shell with 2 electrons. And that's because helium only has 1 energy level. The first energy level can only hold 2 electrons, so it's full with 2. All right. There are a couple of in general, they're non-reactive. When you start getting down towards the bottom of the periodic table, so like xenon and radon, they can react, and it's because of some special circumstances that they have. We'll talk about that when we talk about bonding a little bit later. All right. You don't necessarily need to know that statement of it just yet. They all have 8 valence electrons except for helium. They do not form ions, so they have a 0 for ionic charge. There. They're always neutral. So they don't ever bond on an ionic basis. They always bond on a covalent basis when they do bond. All right. Now, I'm just going to leave all of these showing because the other one that I want you to know for sure is halogen. All right. Halogen is group 7A or group 17. So the name of the group is a halogen. They have 7 valence electrons. All of the halogens are nonmetals. So mostly consists of fluorine, chlorine, bromine, and iodine. The other big thing about these is recall that fluorine, chlorine, bromine, and iodine is part of that group of elements that form those diatomics. So group 7A tends to form diatomic. They're never found by themselves in nature. They're always found either combined with themselves or combined with something else. They're extremely reactive, just like group 1A. And a lot of times in nature, you will find compounds that are group 1A and group 7A elements. So things like NaCl, salt, table salt. That is very commonly found in nature. In fact, up until about 5 years ago, we had one of the largest salt mines in the country in Louisiana. And it was on Avery Island, where they make Tabasco sauce and all of that. The reason why they closed it down is because it started forming a sinkhole. Because the ground became unstable, it was filling in with salt water and causing that. All right. They tend to gain one electron to become more stable, so they have a -1 ionic charge. Remember, you're gaining an electron, you're becoming more negative. Now, so there's a lot of groups in the middle, and we don't focus on those as much. That group that's all labeled with the B's, that's our transition elements. Those transition elements have varying charges. Typically, they all have 2 valence electrons, because what we're doing with those is we're actually filling an inner shell. All right. And then you get to boron, carbon, nitrogen, and oxygen. Each of those groups are named by the first element in the column. So group 3A is boron group. It has it has 3 valence electrons. It makes a +3 charge because it's easier to lose 3 electrons. Carbon group is group 4A. It has 4 valence electrons. Those tend to the metals in that group, the things below the metalloid line, tend to form a +2 or +4 charge. All right, they have a varying charge, and I'll do more of that tomorrow. But the carbon group atoms, they like to make covalent bonds too. All right, so they don't really tend to. They'll either make that positive ion if they're metal, or if they're non-metal, they form covalent bonds, don't make an ion. Nitrogen and phosphorus is group 5A. Again, 5 electrons in the valence shell. They like to form a -3 ion. And then oxygen, sulfur, and selenium, group 6A, have 6 valence electrons. They like to gain 2 electrons and become a -2 overall charge. So when we get to these, the groups that I covered, that I actually put up on the board, those are the ones they're going to ask you questions about in the notes. If you have to look up an element, look up an element. Like I think they refer to montebellium in there. Montebellium is MO. It's a transition metal. So they're going to ask you questions like period versus row, like location. All right, remember, our period versus family, or period versus group. Group are the columns, period is across. All right, so if it says it's in period 4, if it's period 4, family 5B, you locate it like that.